Dart troubleshooting using Java introduction. Dart troubleshooting using Java is understanding common Dart and Flutter problems using concepts familiar to Java developers. Many Java backend developers learn Dart. 4.
Check.
Flutter mobile apps, cross-platform development, front-end integration, full-stack development. A common learning topic is, how do Java developers troubleshoot Dart applications effectively? This guide explains Dart basics for Java developers, common Dart errors, Flutter troubleshooting, async debugging, null safety issues, state management problems, API debugging, performance troubleshooting, memory issues, best practices, real-world examples. This is very useful for Java developers transitioning into Flutter and Dart development. Simple definition. Dart troubleshooting means identifying, debugging, and fixing errors in Dart or Flutter applications. Why Java developers learn Dart? Java developers often move to Dart because of Flutter mobile development, shared backend front-end understanding, modern UI frameworks, full-stack opportunities. Java similarities.
Check.
Object-oriented programming. Check. Classes and inheritance. Check. Interfaces. Check. Asynchronous programming. Check. Exception handling. Java versus Dart basics. Java Dart public class. User class user. String string. Int int. List of user. Null allowed. Strict null safety. JVM Dart VM. Common Dart troubleshooting areas. Syntax errors, null safety errors, async issues, widget rebuild problems, API failures, state management bugs, performance problems, memory leaks. Build errors. Step 1. Understand Dart null safety. One of the biggest changes for Java developers is Dart null safety. Example: string name equals John. Nullable variable. String name. Common error. Null check operator used on a null value. Problem example string. Username. Print username.length. Issue. X username is null. If username equals null, print username.length. Best practice. Avoid unnecessary operators. Step 2. Troubleshoot async issues. Dart uses future, async, await. Similar to Java async concepts. Common async error, future string, fetch data, async, return hello. Void main. String data equals fetch data. Error. A value of type future string can't be assigned to string. Fix. Void main async. String data equals await fetch data. Java comparison. Java. Completable future, string. Dart equivalent. Future, string. Step 3. Handle exceptions properly. Dart exception handling. Try. Int result equals 10, -0. Catch E. Print E. Java equivalent. Try. Catch exception E. Step 4. Debug Flutter widget rebuild issues. Common Flutter issue. Unnecessary widget rebuilds. Symptoms. Slow UI. Slagging. Example. Set state. Counter ++. Problem. Entire widget tree rebuilds. Best practice. Clicky. Minimize rebuild scope. Use proper state management. Step 5. Troubleshoot state management. Common Flutter state tools. Provider, Riverpod, block, getX. Common issue. UI not updating after state change. Example mistake. Counter ++. Without. Notify listeners. Fix. Counter ++. Notify listeners. Step 6. Debug API issues. Example API call. Final response equals await http.get uri.parse https://api.example.com/users. Common problems. Cart. Invalid JSON. Timeout. Wrong endpoint. CORS issues. Null response. Troubleshooting API responses. Always log responses. Print response.status code. Print response.body. Best practice. Validate API contracts carefully. Step 7. Parse JSON safely. Common issue. Type null is not a subtype of type string. Example: name, JSON, name. If field is missing. Runtime error occurs. Safer approach. Name, JSON, name. $. Step 8. Understand late initialization errors. Common error. Late initialization error. Example: late string username. Print username.
Problem.
Variable not initialized. Fix. Username equals John. Or string username. Step 9. Fix Flutter layout errors. Common error. Render flex overflowed, usually caused by large widgets, fixed sizes, missing scrolling. Fix using expanded, flexible, single child scroll view. Step 10. Debug performance problems. Common performance issues. Too many rebuilds. Check. Large widget trees. Unnecessary API calls. Heavy animations. Use Flutter DevTools. Target CPU profiling. Target memory analysis. Target repaint tracking. Step 11. Avoid blocking the UI thread. Heavy computation blocks UI. Bad example. While true. Dot. Fix. Use isolates. Use async processing. Equivalent to Java background threads. Step 12. Understand memory leaks. Common Flutter memory leaks. Unclosed streams. Active listeners. Controllers not disposed. Bad example. Text editing controller. Controller equals text editing controller without cleanup. X. Memory leak possible. Fix. At override. Void dispose. Controller.dispose. Super.dispose. Step 13. Troubleshoot build errors. Common Flutter build issues. Clock, Gradle conflicts. Android SDK mismatch. Package incompatibility. iOS CocoaPods issues. Useful commands. Flutter clean. Flutter pub get. Step 14. Understand dependency problems. Common issue. Version solving failed. Fix. Check. Update package versions. Check. Compatibility. Check. Run dependency upgrade. Command. Flutter pub upgrade. Step 15. Debug navigation issues. Common navigation problem. Navigator operation requested with a context that does not include a navigator. Usually caused by invalid build context. Async navigation timing. Best practice. Navigate from valid widget context. Step 16. Handle hot reload versus hot restart. Feature purpose. Hot reload updates UI quickly. Hot restart restarts app state. Sometimes hot reload is insufficient. Use. Click. Hot restart. Step 17. Debug Firebase integration. Common Firebase issues. Check. SHA key missing. Google services.json mismatch. Check. Authentication failure. Initialization errors. Always verify. Package names. Package names. Firebase project setup. Platform configuration. Step 18. Troubleshoot platform channels. Flutter communicates with native Android iOS code. Common issue. Missing plugin exception. Usually caused by yes, plugin registration issues. Yes, unsupported platform. Yes, rebuild required. Fix. Flutter clean. Then rebuild. Step 19. Use logging properly. Useful logging. Debug print. API response. $. Avoid excessive logs in production. Step 20. Use Dart DevTools. Dart DevTools helps debug. Check memory, performance, widget rebuilds, network requests. Features: timeline analysis, CPU profiler. Common Java to Dart transition mistakes. 1. Ignoring null safety. Dart is stricter than Java. 2. Forgetting async await. Futures must be awaited. 3. Misunderstanding widget rebuilds. Flutter UI is reactive. 4. Blocking main thread. Heavy processing freezes UI. 5. Not disposing resources. Causes memory leaks. Real-world example. Flutter app with Spring Boot backend architecture. Flutter mobile app. REST API. Spring Boot backend. PostgreSQL. Common troubleshooting areas mobile app. State issues. API parsing. Layout bugs. Backend. Authentication errors. JSON mismatch. Timeout handling. Example API parsing issue. Backend response. ID 1. Name John. Flutter model. Factory user from JSON. Map string dynamic JSON. Return user. ID JSON ID. Name JSON name. Understand null safety deeply. Always await futures. Dispose controllers properly. Log API responses. Use DevTools regularly. Keep widgets small. Optimize rebuilds. Validate JSON carefully. Use proper state management. Separate UI and business logic. Common interview questions. 1. What is Dart null safety? Null safety prevents null reference runtime errors by enforcing nullable and non-nullable types. 2. What is a future in Dart? A future represents an asynchronous operation that completes later. 3. Why use async await? It simplifies asynchronous code and improves readability. 4. What causes widget rebuild performance issues? Excessive set state usage and rebuilding large widget trees. 5. Why dispose controllers? To prevent memory leaks and resource retention. Flutter plus Spring Boot system design. Flutter mobile app, down, API gateway, Spring Boot services, PostgreSQL database, Redis cache. Final summary. Dart troubleshooting for Java developers becomes easier when understanding. Check. Null safety. Futures and async await. Flutter widget lifecycle. State management. API integration. Memory management. Reactive UI updates. Java developers already understand many core programming concepts, making Dart and Flutter easier to learn. Key idea. Most Dart and Flutter issues come from null safety, async handling, widget rebuilds, state management, and improper resource cleanup.